of a message. The declaration of a method consists of the method type identifier, a return type, one or more signature keywords, and the parameter type and name information. Here's the declaration of the insert_object@index instance method. For instance methods, the declaration is preceded by a minus sign. For class methods, the corresponding indicator is a plus sign. Class methods below describes class methods in greater detail. A method's actual name, insert_object@index, is a concatenation of all of the signature keywords, including colon characters. The colon characters declare the presence of a parameter. In the above example, the method takes two parameters. If a method has no parameters, you omit the colon after the first, and only, signature keyword. When you want to call a method, you do so by sending a message to the object that implements the method, or, in other words, messaging that object. Although the phrase sending a message is commonly used as a synonym for calling a method, the Objective-C runtime does the actual sending. A message is the method name, along with the parameter information the method needs, properly conforming to type. All messages you send to an object are dispatched dynamically, thus facilitating the polymorphic behavior of Objective-C classes. Polymorphism refers to the ability of different types of objects to respond to the same message. Sometimes the method invoked is implemented by a superclass of the class of the object receiving the message. To dispatch a message, the runtime requires a message expression. A message expression encloses with brackets, and the message itself, along with any required parameters, and just inside the leftmost bracket, the object receiving the message. For example, to send the insert_object@index message to an object held by the myArray variable, you would use the following syntax. To avoid declaring numerous local variables to store temporary results, Objective-C lets you nest message expressions. The return value from each nested expression is used as a parameter or as the receiving object of another message. For example, you could replace any of the variables used in the previous example with messages to retrieve the values. Thus, if you had another object called myAppObject that had methods for accessing the array object and the object to insert into the array, you could write the preceding example to look something like the following. Objective-C also provides a dot syntax for invoking accessor methods. Accessor methods get and set the state of an object, and thus are key to encapsulation, which is an important feature of all objects. Objects encapsulate, or hide, their state, and present an interface common to all instances for accessing that state. Using dot syntax, you could rewrite the previous example as. You can also use dot syntax for assignment. This syntax is simply a different way to write myAppObject set the array :new array. You have used dot syntax already for assigning to a variable in your first iOS app. Although the preceding example sent messages to an instance of a class, you can also send messages to the class itself. A class is an object of type class created by the runtime. When messaging a class, the method you specify must be defined as a class method instead of an instance method. Class methods are a feature similar to static class methods in C++. You often use class methods as factory methods to create new instances of the class or for accessing some piece of shared information associated with the class. The syntax for a class method declaration is identical to that of an instance method, except that you use a plus sign instead of a minus sign for the method type identifier. The following example illustrates how you use a class method as a factory method for a class. In this case, the array method is a class method on the NSArray class and inherited by NSMutableArray that allocates and initializes a new instance of the class and returns it to your code. A property in the general sense is an item of state encapsulated by an object. It is either an attribute, such as a name, or a color, or a relationship to one or more other objects. The class of an object defines an interface that enables users of its objects to get and set the values of encapsulated properties. The methods that perform this function are called accessor methods. There are two types of accessor methods, and each method must conform to a naming convention. A getter accessor method, which returns the value of a property, has the same name as the property. A setter accessor method, which sets a new value for a property, has the form setPropertyName, where the first letter of the property name is capitalized. Properly named accessor methods are a critical element of several technologies of the Objective-C frameworks. Objective-C offers declared properties as a notational convenience for the declaration and sometimes the implementation of accessor methods. In your first iOS app, you declared the username property. Declared properties eliminate the need to implement a getter and setter method for each property exposed in the class. Instead, you specify the behavior you want using the property declaration, and then ask the compiler to synthesize or create actual getter and setter methods based on that declaration. Declared properties reduce the amount of boilerplate code you have to write and, as a result, make your code much cleaner and less error-prone. You include property declarations with the method declarations in your class interface. The basic declaration uses the @property compiler directive, followed by the type information and name of the property. You can also configure the property with custom options, which define how the accessor methods behave, whether the property is a weak reference, and whether it is read-only. The options are in parentheses following the @property directive. The following lines of code illustrate a few more property declarations. In your class implementation, you can use the @synthesize compiler directive to ask the compiler to generate the accessor methods according to the specification in the declaration. You can combine the @synthesize statements in a single line, if you want. In a @synthesize directive, you can also instruct the compiler to add a corresponding instance variable to your class definition. To add an instance variable after the property name, specify an equal sign and the name you want for the instance variable. Blocks are objects that encapsulate a unit of work, or, in less abstract terms, a segment of code that can be executed at any time. They are essentially portable and anonymous functions that one can pass in as parameters of methods and functions, or that can be returned from methods and functions. Blocks themselves have a type parameter list, and may have an inferred or a declared return type. You can also assign a block to a variable, and then call it just as you would a function. The caret symbol, circumflex, is used as a syntactic marker for blocks. There are other, familiar syntactic conventions for parameters, return values, and body of the block, that is, the executed code. The following figure explicates the syntax. Specifically, when assigning a block to a variable, you can then call the block variable as if it were a function. A block shares data in the local lexical scope. This characteristic of blocks is useful because if you implement a method and that method defines a block, the block has access to the local variables and parameters of the method, including stack variables, as well as to functions and global variables, including instance variables. This access is read-only, but if a variable is declared with the block modifier, its value can be changed within the block. Even after the method or function enclosing a block has returned, and its local scope is destroyed, the local variables persist as part of the block object as long as there is a reference to the block. As method or function parameters, blocks can serve as a callback. When invoked, the method or function performs some work, and, at the appropriate moments, calls back to the invoking code via the block to request additional information or to obtain program-specific behavior from it. Blocks enable the caller to provide the callback code at the point of invocation. Instead of packaging the required data in a context structure, blocks capture data from the same lexical scope as the host method or function. Because the block code does not have to be implemented in a separate method or function, your implementation code can be simpler and easier to understand. Objective-C frameworks have many methods with block parameters. For example, the UIKit framework declares the following class method, which has two parameters that take blocks. This method enables